Welcome back, Windows Server Administration Fundamentals. We are on Module 3, Managing Storage. I am Thomas Willingham. I am here with...
Christopher Chapman. I like that that's all I have to say in the beginning. Christopher Chapman. And then I just sit back quietly and wait for demos.
Wait for stuff to happen.
It's a good system for me.
Works for both of us, and it might hopefully work for them.
I hope so.
Hopefully
Kind of the goal of this whole exercise.
So, managing storage. Let's talk about our objectives. Skills concepts, identify storage technologies, same as the domain description. Introduce redundant array of independent disks. People are probably more familiar with the term RAID. And then understanding disk structure and understanding disk types. So storage.
You need a lot of it.
Lots of it. We've talked about a motherboard, which is the system, the hub that houses your processor, your RAM, your network card, your VGA card. We've talked about the processor, we've talked about RAM, we've talked about your network card, and we've talked about storage. Storage enables you to hold data. The more storage you have, the more data that you can hold. Although nowadays there are technologies that do tiering, that do deduping, that allow you to maximize your storage, but at the end of the day, you still need a place to hold your stuff.
Yep.
Which is what storage is. You need sufficient processing power to access your storage and to process the information coming to and from your storage.
And in some cases, adequate network to do the same thing.
Correct.
Which we'll talk about.
Correct. Simple servers, well, if there is such a thing as basic servers. So servers with basic functionality might just have IDE drives, just a straightforward drive connected into the motherboard. But there are numerous types of technologies, storage technologies. There's LANs, there's SANs, there are SCSI hard drives, there's network attached storage. There's numerous types of storage. Pause. Thank you.
There's numerous types of storage.
Yeah, I'll just cut over to this. Whenever you're ready.
Okay. So we've talked about numerous types of storage. SANs, NAS, RAD, SCSI hard drives. So the first type of storage that we'll talk about is RAID, redundant array of independent disks. So redundant array of independent disks, or RAID, uses two or more physical drives together to create some type of new disk system. It says fault-tolerant system, but there actually is a level of RAID that has no fault tolerance to it.
It's not fault-tolerant. In fact, it's fault-increasing.
Correct. Because now you have more areas of exposure to failure. Most drives are, and we've discussed this, half electronic, half mechanical. That picture of the drive with the platters, with the little
arms,
readers,
yep.
little arms on it. Multiple drives are typically connected to increase storage. RAID can be implemented using hardware and software. Typically, it's a combination of both. Typically, you have a hardware controller for your RAID and then software that controls the hardware. So RAID 0. I mentioned that not all levels of RAID are fault tolerant. RAID 0 is that RAID. It stripes data across multiple drives. So now if one drive, either of those drives fails, you've lost all your data. They've shown that as drives increase in age, their likelihood of failure increases. It's not a matter of, honestly, it's just a matter of when they're going to fail. They will fail eventually. And just know that you need to take the proper precautions for drive failure. You perform your backups, you use appropriate level of RAID. But one thing that RAID 0 does nicely is it load balances. So if you have multiple drives, instead of a single drive having to take care of all the reads and writes, now you have multiple drives comparing reads and writes. Notice how my hands do. Oh, dude, my hands are magic. They do a lot of things here. First, they were servers and clients. Now they're drives. I mean, there's a lot going on here. I'm just saying.
That's good. That's good.
Just bringing it up. RAID 1. RAID level 1 is sometimes referred to as disk mirroring. And what that is you have information that's written on one drive that is also written on another drive. So if either one of these drives fail, you still have the complete set of information on another. If one of these fails, you'll take the drive out. Some drives are called hot swappable, which means while they're still powered on, you can remove a drive and replace it, and it will rebuild it. Others, you will actually have to turn the system off, replace the drive. It just depends on the level of RAID that you have. Typically, rebuilding a mirrored system, some of the newer ones will do it on the fly with minimal decrease to the system. Some of the older ones, as you're rebuilding a mirrored system, can take a bit of time and quite a CPU load.
Well, the downside to RAID 1, 50% data loss.
Correct.
50% storage capacity loss.
Correct. So if you have two drives of 100 gigs each, so effectively you have 200 gigs worth of storage, you can only use 100 gigs of that storage. Yep. RAID level 5. RAID level 5 is a striped set, only this has a parity bit in the system. So now if one of these drives fails, it can be removed, and using that striped set, all that data can be rebuilt. So if any one drive fails, the system can continue to run, and then the parity calculations can be performed to ensure that no data is lost. At the appropriate time, one of these can be removed and a new one can be set. In some of these systems, I've seen there's actually a spare hard drive that is empty that's waiting, and when one of those drives fails, it automatically just spins that drive up and then starts copying the data to that drive.
Called a hot spare.
Hot spare. Very nice. And then hybrid levels of RAID. So hybrid levels of RAID is implementing multiple levels of RAID simultaneously. So maybe you use RAID 0 and 1 together. So 0 is a striped set. So you combined separate drives into a single drive. So two physically separate drives shown to the system as like drive C or drive D. This enables you to get the benefit of load balancing through a striped set, but now you have the fault tolerance of a mirrored set. Again, using mirror, you lose 50% of your system, but that just depends on what type of drive system you want. Some drive systems are more expensive. Maybe this wouldn't be the most effective. Some drive systems that are cheaper, this might be the way to go for you. We've discussed a little bit about a hot spare already, so that drive that's just waiting to be used. It's active, it's connective. When one drive fails, it immediately gets picked up.
It's like we plan these. It really is.
Again, you'd think that maybe we'd done this before.
Turns out.
Luckily for us, luckily for them. So, hot spares, kind of exciting, kind of an interesting thing.
I can remember being new to each thing I learned as I learned it in IT. And you get a RAID array and you're like, this is cool. And then you get a more expensive like RAID enclosure where you have hot spares. And it's, I don't know, it just felt like every time I got to an environment where there was some new technology I hadn't used before, I hadn't seen before, I hadn't experienced before, I felt like I was like, moving up in my career. So everything was even cooler because I'm like, wow, now I'm working with hot spares. This is just awesome. And now I'm like, oh, storage, I don't want to deal with that headache. It's so much work.
I remember the first time somebody showed me a hot swappable drive. I didn't really understand what the system was. I mean, they told me, oh, hey, you know, I can live take a drive out, I can put a new one in, and I'll show it to you. And I'm like, okay. So logically, I understood how it worked. But when the person went up and yanked the drive out while the system was running, I was like, it kind of startled me. I was like, what are you doing? Then they stuck the new one in. It continued to run. At the time, it was magic.
I still like doing stuff like that. I like managing IT departments and messing with them. What happens if I pull this drive out? Nothing, hopefully.
Hopefully nothing.
Who knows what's going to happen? And
Hopefully nothing.
It's a nice little test. Don't recommend that in your workplaces. Don't go to work tomorrow or today.
And just start randomly powering off
stuff off.
system, yanking power
But
cords.
I'm one for testing, real world scenarios. Walking and unplugging a network cable. Can anybody tell me what that network cable's for and what just might have happened or didn't happen? Hope your
So then you
labeling.
hear screaming from
Hope your
another
labeling
side.
is correct. Yeah, so it's drives can be the same way depending on which one you pull.
Okay. A long time ago, in an office, it was a small office,
Far away.
far away. None of the cabling was labeled. We had to do that. We had to, while people were working, they weren't working, they knew we were going to do this. We had them surfing the web or whatever, and we'd unplug cables and listen to who went, hey, that's mine. Oh, okay,
That is horrible.
Yeah, it was painful.
Wow.
I don't miss having to do cabling. Not fun times. So, storage, network attached storage. Now we're talking about network attached storage, or NAS, is file level data storage device connected to a computer network. So, it's storage connected directly to the network. Providing shared files folders, typically using SMB or CIFS. Typically contain multiple drives, using some type of fault tolerance like RAID, and managed, since there's no computer directly connected, using a web interface. So that's network attached storage. Storage area network is an architecture for disk arrays, tape libraries, and optical jukeboxes that appear as locally attached drives on the server. Again, uses some type of fault-tolerant technology, providing some system redundancy against drive failure, typically contains spare drives, and to provide a high level of data throughput, they normally have a high-level throughput device, SCSI protocol, iSCSI fiber channel interface to connect these to the computer devices that they're supporting. So it's not like they're using typical Ethernet. They're using like a fiber channel or a gigabit or something.
Hopefully.
Hopefully. Hopefully. HBA host bus adapters connect a host system, such as a computer, to a network or storage device. So this is just a connectivity
Well, and this
device.
is something that I'm going to chime in here because this is something that kind of frustrated me a few years ago when I first started learning about SANs. A host bus adapter sounded like some specialized device that I needed to have to do something specific to get this thing to talk to a SAN, and it's not necessarily. If you're using iSCSI, use a network card. It's a network card. If you're using fiber channel, you're going to use a fiber card. Now, is that fiber card any different than just a regular fiber-based network adapter? Not necessarily. It may just be a fiber NIC. So when they say host bus adapter, it always kind of threw me because I thought for a long time it was a specialized device or a specialized card, and it's not.
It's naming the functionality.
Yeah.
That's a great point.
Yeah, and they're trying to pull, I think the intent is to pull away the idea of it being a network card because you're not using it to connect your computer to the network. You're
To
using it for a
associate the
specific
specialized
function.
functionality. LUNs, logical unit numbers.
The way you said that. Look, LUNs.
LUNs.
Angry.
Oh, no, not angry at all. Just ensuring proper enunciation.
Well, and if you want, while you talk about this, you can go back to the picture I'd put in because there's a graphical representation of a LUN right there. So you've got your computers connected to your storage area network devices, your switches, which connect to your disk array. That disk array has all the disks in it that you've carved up however you want. and then your LUNs are within those, and the LUNs are right there in the lower right.
Yep. They are unique identifiers for an area on a disk.
Yep. And on a disk, again, a little bit tricky because if you look at that diagram, you're not on a disk per se. And this is where SANs get a little tricky because there are layers to it. I may be sitting at a computer looking at drive F that's on a SAN somewhere. Drive F is not a hard drive in this box, clearly. It also may not be a hard drive on that box. It may be 10 hard drives on that
10 drives,
box
yep.
that are put together in a giant RAID 5 array. And then even that RAID 5 array could then be partitioned into LUNs, and my drive F is just one LUN on that RAID 5 array. So that's where, that's actually kind of glad I came up with that story.
That was good.
Yeah,
that was really good.
I feel much better now. It's layers, so you got to be tricky, or you got to be careful. If you're administering this, you'll know how to do it really well. If you're not trying to piece together where the things are, where they fit, where the LUNs live, it can be a little tricky because of those layers.
So I think we could say a LUN is a unique identifier for an area of storage.
Yep, for some space somewhere.
Yes, not specifically a disk,
Correct.
necessarily. SAN connectivity. So this goes back to HBA, host bus adapters, fiber channel, iSCSI. So these are just the different connectivity devices to enable SAN connectivity. And next we have a demo for iSCSI initiator software.
All right, so let me pull this up. I'm not sure I have it on this one. I may have to jump to it. Oh, I do. No, I'll go to the other server. I'm going to go to my 2012 server because it's already running. There. All right, so I'm on 2012. I actually have the iSCSI initiator right here because I use a SAN at my house. I'm that guy. I don't go out much. So here is my iSCSI initiator. And all this is, it's an endpoint for a connection to a SAN through Windows Server. Whatever adapter you have that's connected to whatever network you're using for storage, once that's published, this will find it, and you use this to maintain the connection between that SAN and the drive that you're using. So I think it's this one. It might be this one. But one of these is not a local hard drive. Although, just for fun, I will show this off, because this is something that also blew my mind early on. Let's go back to compmgmt. And we're going to look at drives. Now, we haven't done this. We're going to do this later as part of another section. I think in this module, it might actually be a demo coming up here in a second.
I believe so.
So I'm in disk management, which is where I do exactly that. I manage disks. Some interesting things to see here. D is a mirror. I have a mirror that I've created, a Windows managed mirror in this box. I also have a G drive. This is a SanDisk. This is not a local drive attached to this box. That is what my iSCSI initiator is connecting to. So once you've got this up and running, it will appear in here as just another drive. Something you will have to document and be aware of is that very thing. G is not a drive that's in the box. If something happens and it disappears, which I've had happen, if your SAN fails, something goes wrong, that iSCSI initiator won't be able to connect. Your G drive is going to vanish. If you're not keeping track of what's where and what and why and how, you're going to think, oh, the drive in the box is bad, and go tearing apart servers trying to find a bad hard drive. Well, it's not in the server. So things to consider when you're talking about SANs.
And this goes back to the perfect example of network documentation.
Yes.
Ensuring that your network is documented on many different layers. I mean, you need to ensure that the server hardware and software is documented. The drives, the storage systems for the server is documented. Your clients are documented. The protocols used to communicate between your servers and your clients, your addresses. So there's a whole bunch of layers of. And there are tools that help you perform that management, that system management. System Center, for example,
Is amazing.
can help you
Yep.
manage that. Storage Explorer. This is not Dora's Brother Storage. This is Storage
Wow.
Explorer. See, look at that. I am a man of the people. And I am able to throw out a Dora the Explorer reference.
So Storage Explorer is, I'm going to bring up Windows 2008. I'm on my 2008 server. Here's Storage Explorer. It's not connected to anything, this particular server. It's just a standalone. So there are no fabrics in Fibre Channel or iSCSI. But this is where I could check that if I did have this server connected to a SAN somewhere.
So this enables you to manage those SAN devices, view and manage the fiber channels, the iSCSI fabrics that are available in your SAN.
Yep. In fact, let's try something. This is a little test for me. I didn't actually plan on doing this, but let's try and see what happens. Let's see. Trying to get my own IP address because I don't remember. Oh, that's not going to work. Exit is not an IP address on my network. So as soon as I put in a target, it comes, or a server, a SAN server, it comes up with the target because I've already created the target. Connect. That's fine. And now I'm connected. Now I'm doing this for a couple of different reasons. First, we're going to go to disk management. And we're going to see what this looks like here. I've connected to the SAN. That's it. This is the first thing it's going to do. It's going to ask me to initialize the disk. Now you'll notice after that's done, it's offline. That's by default. And I'm not going to be able to online it. If I online it here, it'll take it offline on my other server, which I don't want to do. Now we go to Storage Explorer and refresh. I might have to close and reopen Storage Explorer. Nope, still not coming up with any fabrics. I don't have a full, like an iSCSI. Did we talk about fabrics? I know it was like 10 minutes ago.
A little bit.
I don't have an actually redundant storage area network. I have a computer and a switch and another computer. There's no complication to it, so we may not be quite as functional as we want to be in this case. Servers, server web, here we go. I mean, I can see this. All I can see is my actual target connection. No fabric. And I can control it through here. One nice thing is you can see I can log on and log out of the target. I can actually control that iSCSI initiator to some degree through here. But it's limited, but it's something.
So that was Storage Explorer. Now, disk structure. Before you use the disk, you need to. So a disk just is a raw structure. To enable use of that disk, you must first partition it appropriately. So you can have the entire disk as a single partition, or you can chop it up. Once you've created partitions, you need to create volumes and format the partition. When you use a disk in Windows, you need to figure out the disk partition style, basic, different types, the disk type, the type of volume that you're going to create, and the file system you're going to use. So partitioning, so you can divide a physical hard drive into multiple partitions. It used to be that the FAT16 file system only had like 2 gigabytes that could be used. So if you had a drive over 2 gigabytes, you had to partition it appropriately. So partitioning enables you to define storage areas of storage to be used for the drive. Each partition functions as a separate drive to the computer. So to the computer, as far as storage is concerned, it's a physically separate disk.
Same idea with the SAN. It's going to show up as C, D, E, F.
Correct.
Even if it's all one physical drive.
And then to keep track of how it's partitioned, it uses a partition table. And then once you've partitioned a drive, you need to format it. And to format it just basically lays it down and says, oh, okay, I'm going to create an area that can be used. Here's partitioning. You're segmenting it and saying, hey, here's an area of raw storage that can be used. When you format it, you put it in a state that the operating system can use. Mm-hmm. Partitioning style refers to the method used to organize a partition on the disk. Two types of partitions are supported here: the master boot record, MBR, or the GUID partition table, GPT. Windows hard disk storage. Most versions of servers support two types of hard disk storage: basic and dynamic. Basic, traditional types. Dynamic enables the ability to change the disk size while it's running. And you can do this without rebooting. The volume types are simple, spanned, striped, mirrored, and RAID 5. File systems. Your file systems are, so you've partitioned an area, it's a raw area of storage waiting to be, and right now, let me just step back and say, right now, we're barely scratching the surface on storage. We're doing such a high level. There are week-long courses devoted to like network storage, different types of storage methods. So again, we're barely scratching the surface. So the file system is a method of organizing content and data on the disk. Makes the data easier to find so the operating system can find data that it's put on the system. It maintains the physical location of the files and the data so you can find and access the files later. 2008 supports FAT16, 32, and NTFS. And then 2012 added support for REFS. REFS. Fancy.
Fancy indeed.
FAT16 and FAT32 were the original, well, FAT16 originally called FAT, File Allocation Table, came out with DOS. It only supported up to 2 gigs. And initially that seemed like amazing. That's when we had, on like big systems, you had 4 megs of RAM. You might have 4 megs of RAM on your server.
And 150, 200 meg hard disk.
Correct. That we would never fill. Oh, we'll never fill 100 megs. That's just crazy. FAT32 was released with Windows 95 and enabled storage initially up to 32 gigs. It's pretty slick. NTFS came out. New technology file system. Ooh. It supported much larger hard disks, up to 16 exabytes, and long file names.
Yes, we finally got away from the 8.3 file name 8.3.
Yes, NTFS supported more of a Unix type system where file names could be whatever.
Whatever, yeah, pretty much.
Yeah. It's more fault tolerant than previous file systems. It says it uses journaling. And we're not talking about writing its feelings in a notebook.
That's true or not.
It just ensures that disk transactions are written appropriately to the drive so they can be recognized. NTFS also enables more permissions and security and encryption.
Well, it enables any permissions and security.
So the FAT table had file attributes, so it could be read-only, read-write, but at a file level. NTFS enabled permissions, so user A has these permissions on these sets of files.
Yep.
So it was a more robust file system that enabled more additional features and functionality. Disk management. So we have these disks, we've created partitions, we've formatted them using the format type that we want, FAT, NTFS. Most of the time nowadays we're just using NTFS. Disk management is a MMC snap-in called amazingly enough, disk management.
We just saw it a couple minutes ago.
That we just saw. And not to drive this home, but it enables disk management.
It does. It turns out.
Management of disks.
Crazy. I think there's a demo coming up for that now.
Yeah, but you kind of went over
I did it
pretty extensively.
I'm ahead of myself on the demos.
Did you want to format a drive?
No. I don't have any I can, but I can show people. I had intended on showing them. So we'll jump in here, and we will switch to that one. 2 ways to do this. I'll just do Format C. Warning, all data will be lost. Probably not a good idea.
No.
But it's pretty much that simple. Here are your options.
Now, one option to make something bootable, to make a drive bootable, is it the /S
Yep.
option for system format. So now you're not only formatting a disk, you're creating boot up information on it.
It was S. I'm
it
not
not
sure
S anymore?
it's not something you really have to do anymore the same way you used to.
Oh, yeah.
So
I haven't formatted a disk in ages.
Well, and I can also do this, which a lot of people, I know most people either do it via the command line or
Disk management.
or in disk management when they format. But there is a tool. I need to see if it can be done here. God, I cannot remember the way to do it. There was a tool, a separate standalone format tool with a graphical interface you could use at one point.
Oh, okay.
It's been a long time. It may not even be available in Windows 8, 8.1, Server 2012, and I can't pull it up because of that. I don't know, but there used to be a little standalone format graphical tool that you could use. But disk management's the way that I use. It's the way that most people managing servers use, I would assume. Unless you're using automation tools like ConfigMan, which will do all sorts of fun things to all of your servers. So here, let's scroll up. Oh, interesting. Unallocated space. I should do something with that. Here, I could format this. In this case, it has been. Yeah, I'm not going to be able to change it. And these have already been done. I can't do anything with them. Yeah, see, I can't format any because they're all in use. Oh, I could do this, but I mean, it's not going to work because it's a system partition.
Right.
So I can't actually bring up the graphical interface here for formatting. Let me see if I can do it here. There we go. There's at least the interface. File system. We're not going to get into allocation unit size. There's a whole conversation in the world about allocation unit size and making sure that the size that you choose lines up correctly with the physical disk itself and how the sectors are arranged and performance.
And what type of data are you putting on it? Are you putting large chunk data? Are you putting small chunk data?
Whole worlds of conversation about allocation unit sizes on NTFS volume. So have fun looking that up in your spare time. And that's all. That's all I'm going to show you. I'm not actually going to format one because I don't have any extra disks to format.
Fair enough. But they get the idea. I mean, you click OK, you hit yes, it chunks a bit, and then you have usable space.
Yep.
Yay, usable space. Oh, look at where we're at.
And again?
The end.
This one's correct. 98365. There's a book. There's a course. There's an exam.
There's an exam. There's things and stuff that you can do to continue on in your education, in your pursuit of knowledge.
And you should partake of those things and stuff.
You should.
We'll be back in Module 4.
Module 4, it is. See you real soon, I hope. Hope so. Come back.